All right, so we have the array version. Let's go ahead and do the linked list version. And I already have my code for stack test and main, so I already have some test code. So I'm going to do a little trick here, and I'm just going to I'm going to copy my stack.cpp to stack.cpp.array, and stack.hpp to stack.hpp.array. And now I should be free to edit my stack, CPP, and HPP for the linked list implementation. Oops, stack, CPP. Okay, let me go ahead and do this cleanup, because we're going to be implementing this completely differently, and we actually aren't going to need increase capacity. We have main. Main's going to stay the same. Great. We'll get rid of incapacity, and now we're back here. Okay, so now we're going to do it with a linked list. What do we need to do first? I think that was your first question before we got off the train of the array implementation. Create a node. So we need to. So class, we'll call it stack node. And for the sake of time, I'm going to make these public. So we have mval and stack node mnext. Right? So there's our node. Did y'all do structs? A little bit? In procedural? Yeah, structs are basically a class where you can't have functions and everything is public. All right, so we have a stack node. What is pretty much going to be the one thing of our linked list? What do we need to store? The head. All right, that's actually it. What's mhead start as? Null. Good. We'll get to the destructor later. We're going to push a value. How do we push a value? What's the first thing we do? Create a node. We'll have new node mval equal to val, and new node dash mnext equal to mhead. And then what's the last thing we do? So let me write this. First, create the node. And this one is make it point to the head. And then lastly, update head to start with the new node. Anyone confused by this? If you notice, that's what we've been doing up here. If you had it null, we created 42, had it point to null. If you already had 42, you create a new node, had the new node point to 42, and then the top or the head point to 17. Everyone good? Mm-hmm. All right. How do we pop? Okay, create a temp, sure. And that's set it to mhead, because that's all we have. Now what do we do? Yeah, so mhead equals mhead mnext. Yep. All right. Getting a little confusion? No, because temp, you need it in order to be able to delete it afterwards. And we'll also do good coding practice. So, well, if you deleted the head up here, you wouldn't be able to get head-mnext because that code that would have already been deleted. So we need to keep a temporary pointer going to what needs to be deleted, move our guy down, then delete what we no longer are using, set it to null just as a defensive measure against future evil coders, which may be yourself. All right, top. Yeah. And peak?
Top.
Yeah, there you go. Remember, return top. All right. Hey, we've written test cases already, so let's do it. Whoops. What did I call it? I called it something else in order to fix a different error. Oh, and I'm also not in source. Make stack dash test. Oh, almost there. Mval, a new node is now type class. All right. Mval. Whoa, what's going on here? Non-class stack node. Mval. 914. We should probably do that. Yeah, what I just did back there does not make any sense. I was amazed it actually did something. And also it's called a stack node. Come on, guys. There we go. Oh, seg fault. Whew. Oh, burn. Oh, that was a little rough. Can anyone point out or think about why we're seg faulting?
There's gotta be a point or something wrong with pointing.
Nice. Nice. All right. See, Tyler can, yeah, he's got it. Got the basics. All right, good. Let's Valgrind it real quick.
I know, they've been doing the same thing.
Invalid read of size 8 at line 26. 26. Yep.
We didn't delete, we did.
When would this be bad?
We try to delete null or to
Yes. Well, what if mhead was null?
There's no null. The eminence of null doesn't make sense.
Right. All right, so what do we need to do first? In all actuality?
Check if it's empty.
Yeah. Return if the stack is empty. If, and how do we do that? If mhead, yep. Which one? Which one? Which one? All right, there we go.
Do we have to return anything?
Nope, it's a void. Unlike other pops where you would return something, this one doesn't. All right, let's see if we get the same problem. Oh, wow. All right. And actually, no, wait, that might have been it. Let me see if I see anything else. Nope, we're good. Oh, no, we're not.
Yeah, the top. Same thing for top. Try to return the invalid top.
Right, yeah, we need to do that too. If, well, yeah. Okay, that's a good question. Good point. By C++ convention, we let this be a seg fault. Okay, yeah, I know, hold on. Wait, yeah, hold on. Hold on. Hold on. Hold on. By convention, we're not going to check, because if mhead is null, what are we returning? Well, we can't return null, we have to return integer. Well, what if I mean, how do you know that's not what is actually on top, right? So by convention, we let this be a seg fault to force the programmer to do the check, because the programmer should be, well, we could do a size and find out what the size is, or is empty, and it could check if the stack is empty as well, and then they could do it from there. So this is just pushing the error onto the programmer. In general, that is a bad thing to do, but by C++ convention, they wanted you to do it this way. All right? All the people talked for a very long time and decided this is the way to do it.
It's not the hate seg fault in this situation. Okay.
I agree. That's what, yeah, all the people got together, and if you've ever been to one of these standards conventions, they will talk nonstop forever until you just don't care anymore and you just want to go home. But anyways, that's what they eventually decided, okay?
And that's why it's like.
So we're going to leave this unless you want to go talk to those people again.
Let's just make the second. Can we go home?
Exactly. Thank you. Exactly. There you go. Let's all go home. All right, so we got that. Yeah, okay, hold on. I was going back and forth thinking there was something else, but we are almost there because we are definitely lost a lot of stuff. Hey, look, almost 1.5 megs. What did we forget to do? Delete. Yeah, we forgot to delete. All right, guys. Here we go. There's an easy way and a hard way to do this destructor. Yeah, what's the easy way?
Delete brackets.
Well, if we delete, okay, sure.
No.
So Tyler's saying we should be able to do this. Is that gonna work? Yeah, mhead's not an array. So I'll go Valgrind it right afterwards. Whoops.
That's why you asked about recursion.
Oh, we could do it recursively, but it's actually going to be a lot easier. So we can't just delete mhead. That's just one of the nodes. So we need to go and delete every node.
Can we set just to point to null?
What's that?
Can we set mhead to point to null?
Okay, sure. We can have mhead equals null. But that doesn't delete anything, right? No, it's still there. Good try.
Delete everything. Use a loop.
Using a loop, delete everything. Great. Okay. All right, I'm going to do this the hard way and then the easy way. Here's the hard way. Stack node rover equals mhead. Rover does not equal null. Rover equals rover dash m next. We'll have, actually this is the hard way. Stack node prev equals mhead. What are we gonna do? Mhead. We're gonna have it make equal to null. There we go. Prev equals rover if prev does not equal null. Delete prev. Wow, this is confusing. Delete rover and mhead equals null. Yeah, because this makes perfect sense to y'all, right? No. It does have a lot of mumbo jumbo in it. Oh, we didn't delete rover. Because it's not part of the scope. There we go. Oh, we forgot to free something. Nice, nice literacy. It is something. Okay, hold on. What am I doing here? Because this code's confusing. So we have prev starting at null, and we're going to have rover starting at head. And while rover is not null, we're going to keep pushing rover down the linked list. So rover is going to go down the linked list. Notice that I have prev equal to rover, so prev is always going to point to what's previous to rover.
But when rover becomes null and the loop ends, you're deleting it, so what are you doing?
Oh, I need to delete prev. Thank you.
We did.
No. Those are probably the bytes I'm missing. Oh, that was weird. There. So if rover is null, we still need to delete the last rover, or prev, right? I wonder if that fixes it. Oh, yeah, that was it. Good call. Okay. Is that confusing?
Yes.
All right, let's do it the easy way.
Hold on.
What?
While the stack is not empty, pop it.
So it's empty, just pop it until it is.
Yeah, just keep popping the stack until it's empty. Let me first make sure that worked. Oh, there we go. We already wrote pop. Do we need to write it again? No.
No, you're right.
Yeah. Thank you.
Use what we have.
Use what you have. Don't reinvent the wheel.
3 lines instead of 30.
What's that?
3 lines instead of 30.
Yeah, exactly. 3 lines instead of 30. All right. Any questions on this? All right. All right, we're not going to do the linked list anymore. Great. Oh, one more question? Yes.
I have a question. Why would we want to use a stack?
Why would you want to use a stack? That is a great question. So here we go. Have I used the word stack before today for something?
Stack.
Stack there. What is that?
Memory.
It's memory.
It's a thing you use in Valorant.
And thing you use in Valorant. Okay. Oh, man, I wish I had more time for all this. All right, guys. So there we go.